Modern roof rafters can rot out in 20 or 30 years, while medieval beams overhead in churches, barns and halls are still carrying load after 600. That gap isn't because medieval builders had magic wood or better luck. It's because modern construction violates rules that medieval builders never forgot. Today, we're breaking down exactly why your roof rafters fail faster than medieval beams, what those builders understood about wood and moisture, and how you can fix the problem using logic that predates chemicals, membranes and pressure treatment. The difference begins with how medieval builders understood the enemy. They didn't believe rot came from rain. They knew rot came from trapped moisture. A medieval carpenter expected wood to get wet. What he refused to allow was for that moisture to stay. Modern construction does the opposite. It focuses on sealing, trapping and containing, assuming water can be excluded forever. It can't. Once water enters a sealed system, rot accelerates instead of retreating. So, the first reason modern rafters tend to rot faster is actually down to wood quality and the speed at which it grows. You see, medieval beams were made from slow-grown trees that had dense rings and, well, a high resin content. These trees, they grew under quite a bit of stress and took decades to reach maturity. Nowadays, modern rafters are usually cut from fast-grown plantation timber, which is really designed for speed and yield. But, you know, faster growth leads to wider grain, lower density, and far more internal pathways for moisture and fungi to get in. Sure, you can treat this wood chemically, but you simply can't give it back the structure it never developed in the first place. Cutting season made this difference even larger. You see, medieval timber was felled in winter when sap was dormant and sugars were locked in the roots. That made the wood less attractive to insects and decay organisms from day one. Modern lumber is harvested year-round, often at peak sap flow, then force-dried. Kiln drying removes water fast, but traps internal stress and microfractures that later collect moisture invisibly. The beam looks dry. Internally, it's compromised. The second failure point is, well, how modern roofs handle airflow. You see, medieval roofs were intentionally breathable. Rafters sat in moving air, and any moisture that entered the structure was carried out by passive ventilation through eaves, gaps and ridgelines. Modern roofs are sealed tightly to preserve heat efficiency, but that same sealing, unfortunately, traps moisture inside. Warm air leaks upward, condenses against cold surfaces, and, well, just stays there. Rot doesn't need much time under those conditions. The third problem is surface treatment. You see, medieval builders used finishes that repelled water without sealing wood shut. Pine tar, lime wash and oil-based treatments allowed wood to shed rain and dry really rapidly. Modern rafters are often painted, wrapped or sandwiched between impermeable layers. And once moisture gets behind those layers, it has nowhere to escape. Joinery plays a critical role here. Medieval beams were assembled to move. Peg joints, scarf joints, and interlocking connections allowed expansion and contraction without splitting fibres. These days, rafters are, well, nailed or screwed rigidly into place. Metal fasteners, you see, pierce the wood fibres and, unfortunately, introduce thermal bridges where condensation tends to form. As the wood moves with the seasons, micro-cracks start to open around those fasteners, drawing moisture deeper into the beam. Rot, you know, often begins internally, completely unseen. Roof geometry is, I must say, another often overlooked factor. Medieval roofs were steep for a reason. Snow, rain and debris were shed quickly, so water never lingered. So, modern roofs these days are often shallow, minimalist and, well, pulled tight to the walls. The thing is, water tends to sit there for longer. You also get splashback that reaches the structural members. All this means moisture exposure goes up, while the time for things to dry out, well, it just goes down. Rot isn't, you know, accidental. It's actually engineered right into the design. Now, fixing these problems doesn't mean you need to rebuild your house to look like a medieval hall, but it does mean you'll want to adopt a bit of that medieval logic. The first thing to correct is, well, moisture exit. So improve ventilation wherever you possibly can. So ensure airflow from eaves to ridge so moisture never stagnates. This single change, believe it or not, can double rafter lifespan. The goal here is not absolute dryness, but rather drying. The second correction is material choice and handling. When replacing rafters, do prioritise heartwood over sapwood whenever possible, and allow timber to air dry slowly before installation, rather than relying solely on kiln-dried stock. Avoid sealing beams completely. Instead, use breathable finishes that repel liquid water while still allowing vapour movement. If you must use modern treatments, well, apply them sparingly, and do take the time to understand their limits. The third correction is exposure reduction. Increase overhangs when feasible. Protect structural wood from direct rain rather than assuming coatings will do the job. Redirect water aggressively away from joints and contact points. You see, medieval builders didn't trust materials to resist water. Instead, they trusted design to keep water moving. The final correction is mindset. Medieval builders assumed wood would age. They designed systems that age slowly and predictably. Modern construction tries to freeze wood in time, but that effort always fails. Wood is a living material even after it's cut. Treat it like one, and it rewards you with longevity. If this breakdown changed how you think about rot, rafters and roof design, subscribe to the channel and share this episode with someone planning a build or repair. Relic logic exists to recover the reasoning behind ancient systems that outlasted us, not to romanticize them, but to use them before we forget why they worked.